Let's take a look at this example. First, I'm going to find the inductive susceptance and capacitive susceptance. So I have BL is equal 1 over X of L. This is equal 1 divided by 8 kilo ohms, and don't forget that X of L goes always with angle of 90 degrees. So this is equal 125 microsiemens and angle of negative 90 degrees. Next, I'm supposed to find BC. BC is equal 1 over X of C, which is equal 1 divided by 5 kilo ohms and angle of negative 90 degrees. X of C has to be always with angle negative 90 degrees. This is equal 200 microsiemens and angle of 90 degrees. Okay, so this is my inductive susceptance, this is my capacitive susceptance. Next, we're supposed to find the total susceptance. So B total is equal BL plus BC. So I have 125 microsiemens an angle of negative 90 degrees plus 200 microsiemens and angle of 90 degrees is equal 75 microsiemens and angle of 90 degrees. Okay, so this is my total susceptance. At this moment, it's good to draw admittance diagram. So first we're supposed to draw the complex plane where real axis represents the conductance and the imaginary axis represents my susceptance. Because my B total has angle of 90 degrees, I'm going to draw the diagram in the first quadrant. So this is my B total, right? This is my B total, which is nothing else, just the capacitive susceptance, because capacitive susceptance has angle of 90 degrees. So we found that the B total has 75 microsiemens. So this is let's say 75 microsiemens, and what we're supposed to do next, we're supposed to just draw the phasor, right? Just to visualize what we have to do next. Okay, so we have nothing else, just the right triangle, and this is going to be the G which I'm looking for, and this is my angle theta, and this is my Y total. So far we've found B total, we're supposed to find Y total, and we're supposed to find G. If I'm going to find Y total and I have B total, I can find very easy G. So we are going to use Pythagorean theorem in order to solve G. Y total is equal I total over voltage source. Okay, so we have I total 10 milliamps divided by voltage source, which is equal 120 volts. This is equal 83.33 microsiemens. Okay, so this is the length of my phasor. So please notice that at this moment we have Y total and we have also B total. Okay, so we have two sides of this triangle, so we can find the third one. So as I said, we're supposed to use the Pythagorean theorem, which says that Y total square is equal G square plus B total square. In order to find G, I'm supposed to solve this formula for G. So I have G is equal square root, and I have Y total raised to the second power minus B total raised to the second power. Okay, so this is equal square root, open parenthesis, Y total 83.33 microsiemens raised to the second power minus B total 75 microsiemens raised to the second power. Everything is equal 36.31 microsiemens. Okay, so we found the conductance. Okay, and this is basically what we are looking for. Now we can find the angle theta. Because I have G and I have Y total, I can find very easy angle theta. So theta is equal inverse cosine of G over Y total, which is equal inverse cosine G 36.31 microsiemens over Y total 83.33 microsiemens. Okay, so this is equal 64.16 degrees. Okay, so the angle theta, which I'm going to have for my admittance diagram, is equal 64.16 degrees. Now I can write that Y total is equal 83.33 microsiemens, and I have angle of 64.16 degrees. So this is my total admittance. Now we are ready to find the true power. So write the formula first. Power is equal voltage source, because this is parallel circuit and voltage across each component is equal to the voltage source. So I can write this as voltage source raised to the second power times the conductance, because we have conductance. So I have voltage source equals 120 volts. Because it's not specified if this is peak or peak to peak, I assume that this is RMS. That's why I'm using this formula. Okay, of course I have to raise this to the second power times G, which we found is equal 36.31 microsiemens. Okay, this is equal 522.86 milliwatts. Okay, so this is the true power in my parallel circuit. Next, I'm supposed to find the reactive power at the capacitor. Okay, so what I'm supposed to do? Just write formula. QC is equal, again, voltage source, because voltage source is equal to the voltage across the capacitor, raised to second power, times, in this case, BC. This is equal 120 volts raised to the second power times BC 200 microsiemens. This is equal 2.88 volt ampere reactive. Okay, so this is my reactive power at the capacitor. Next, we're supposed to find the reactive power at the inductor. QL is equal voltage source raised to the second power times BL, which is equal 120 volts raised to the second power 125 microsiemens. This is equal 1.8 volt ampere reactive. Okay, so this is the reactive power at the inductor. Next, we're supposed to find Q total. Okay, so Q total is equal absolute value of QC minus QL. Okay, this is equal. QC is 2.88 volt ampere reactive minus QL 1.8 volt ampere reactive. This is equal 1.08 volt ampere reactive. Okay, so this is one way to solve this problem. Someone can ask how you are going to draw right now the power triangle. You're supposed to just realize that we have given the true power. Okay, we have true power has angle always 0 degrees. Okay, so we have, this is my true power, and this is my total reactive power. Okay, so this is the reactive power, and we're supposed to follow the angle which is next to Z total. We found that the angle theta next to Y total is positive. So if we have positive angle next to the total admittance, so angle next to total impedance is going to be negative. That's why this is going to be my Q total. Okay, it's going to go down because angle next to Z total is going to be negative, so this angle has to be negative, and this is going to be my apparent power. Okay, this is my angle theta, but the problem is not asking me to find apparent power. That's why I'm going to keep going with my calculations. So next we're supposed to find the power factor. Power factor is equal cosine of angle theta. Theta, which is next to Z total. Okay, I'm going to stay with angle next to Z total because later on can be a little bit confusing what I'm supposed to write next to the value of the power factor, or lead or lag. So that's why I prefer to stay with the angle from Z total. So we have cosine of angle theta. Cosine, we found that next to Y total we are going to have angle 64.16 degrees. Okay, but next to Z total we are going to have angle negative 64.16. If someone doesn't understand what I'm talking about, so let me just show you one more time. We got Y total equals 83.33 microsiemens and angle of 64.16 degrees. If you want to find Z total is reciprocal of Y total. Okay, so anytime we have no angle, there is like angle 0 degrees, right? And I have angle over here 64.16 degrees. So if you are going to subtract these two angles, your Z total is going to have angle negative 64.16 degrees. That's why I have negative angle which I'm going to use over here, and this is the same angle which I'm going to use for power triangle. Okay, so just make sure that you are going to remember this very important formula. So this is equal 0.435, and I'm supposed to use word lead. Why? Because I have negative sign next to my angle. Okay, and this is telling me that the total current is going to lead the voltage source by angle 64.16 degrees. So next we're supposed to find the series equivalent circuit. So in order to do so, I'm supposed to simply write formula for Z total one more time. Z total is equal 1 over Y total, but right now you need to switch your calculators to the rectangular mode, okay? And we're supposed to get the answer in rectangular form. So I have 1 divided by, and my Y total, we said, is 83.33 microsiemens, an angle of 64.16 degrees. This is equal 5.23 kilohms minus J 10.8 kilohms, right? Where the real part is my resistor in the series equivalent circuit, and negative J 10.8 kilohms is nothing else just my X of C in my series circuit. Why? Because I have negative J. Okay, negative J is telling me that this is capacitor. So now I can draw my series equivalent circuit. So I have voltage source, and this is my RS, and this is my capacitor, which has capacitive reactance X of C equals 10.8 kilo. Okay. Now we are ready to find the true power in the series equivalent circuit. We found the value of resistor RS equal 5.23 kilohms. So we have I total, so true power in my series equivalent circuit is equal I total square times the resistance RS. So I have 10 milliamps raised to the second power times the resistor RS 5.23 kilohms. This is equal 523 milliwatts. Okay, so this is the true power in my series equivalent circuit. Let me remind you that in parallel circuit we found true power equal to 522.86 milliwatts. So as you can see, these two values are very close to each other. So it means that our calculations at this moment are okay. Next, we're supposed to find the reactive power in the series equivalent circuit. So I'm supposed to write QS, which is equal in this moment QC, right, as in the series circuit, S stands for the series circuit, is equal I total raised to the second power times X of C in the series circuit, right? So this is equal 10 milliamps raised to the second power times X of C as 10.8 kiloohms, right? So QS is equal 1.08 volt ampere reactive, okay? So let me remind you that the value of Q total in the parallel circuit was equal 1.08 volt ampere reactive. So as you can see, these two values are identical. So we can say that the problem is solved correctly.